Hello, hi everyone. So let's continue to part 2, chapter 4, digital modulation, passcode modulation. So for passcode modulation, PCM, it is the most commonly used in digital communication. And in PCM, the available range of signal voltage are divided into levels, and each is assigned a binary number. Each sample is then represented by the binary number representing the level closest to its amplitude, and this number is transmitted in serial form. So in linear PCM, levels are separated by equal voltage gradation. So the pulse code modulation steps is first sampling, next is quantization, and lastly is encoding. So sampling, or the notation is Fs. To retain the high frequency information in the analog signal, a sufficient number of samples must be taken to adequately represent the waveform. So the minimum sampling frequency is twice the highest analog frequency content of the signal. And then this minimum sampling frequency is known as the Nyquist frequency. In practice, the sampling rate is much higher, typically 2.5 to 3 times more than the Nyquist minimum. So here is the equation for frequency sampling. Fs is greater or equal to 2 Fm. Okay. So step 2 is quantization. In PCM, we need to encode each sample value with n bits of binary value. But as number of bits n is limited, it is possible to represent each real value of sample input. To solve this, we must define a finite set of discrete values that call levels, which will then be used to represent the value of sample input. Then, we need to round off the sample input to the closest level. So this process we call as quantization. So here is an example of quantization. So consider this is the PCM table. So we have 0 to 7 level, and this is the quantized value, and this is the voltage range. It's between -2 to 6. So let's say the output of the sampling are as follows. At T1, V1 equals to 4.4. So the quantized value will be, so we need to find the closest of 4.4. It is in between the value of 4 to 5 volt. So the quantized value will be 4.5 volt. Next, T2. V2 equals to 4.45 volt. So it is in between 4 to 5. So still same, the quantized value, which is the closest value, is at level 6 or 4.5 volt. Next is at T3, 4.6. So still at this range, and the closest value is 4.5 volt. And let's try at T4, V4 equals to 3.5 volts. So the value is in this range, 3 to 4 volts, and the quantized value is 3.5 volt at level 5. So quantization, the number of levels available depends on the number of bits used to express the sample value. It is just the M-array series. So the number of levels is given by L equals to 2 to the power of n, where L is the number of levels and n is the number bit per sample. So let's try example 1. The number of level 2 bit per sample is L equals to 2 power of 2 equals to 4, meaning that you have 0, 0 for level 1, 0, 1, 1, 0, and 1, 1. So we have here 4 level and 2 bits per sample. So let's try this exercise 1. Find the number of level for the following PCM system. For 3-bit PCM, the level is L equals to 2 to power of 3, and it is equal to 8 levels. Let's try this one. L equals to 2 power of 8. The answer is 256 level. So, another step in quantization is quantization intervals, which is delta V, or other words we call as step size. Represent the voltage value for each quantized level. So, smallest analog voltage change that can be distinguished with delta V equals to M maximum minus M minimum divided by level. So where M maximum is highest voltage value for the analog signal, and M minimum is the lowest voltage value for the analog signal, and L is the number of level. So example 1, given an analog signal as shown in the figure below with the highest amplitude 4 volt and the lowest amplitude negative 4 volt. So the signal is then sampled by sampling pulses. The analog signal and the output are shown below. So let's say we use 2 bit per sample, meaning that our level now is 4. So therefore, the quantized interval or the step size is equal to M maximum is 4 minus M minimum is negative 4 divided by L, which is 4. So 8 volt divided by 4 equals to 2 volt. So the step size for this example is 2 volt. We can say that the minimum value in a level is 2 volt. Next step is to build up the PCM table. So we need to find the voltage value for each level and then find the middle voltage or the quantized value for each level. So after we know the delta V, we partition this graph signal with start with negative 4 volt and then negative 2 volt, which is the step size is same for each level. So here is 2, here is 2 volt, and here is 4 volt. Alright. So the middle voltage for each quantized level, for the level 0, so here is level 0, here is level 1, here is level 2, and here is level 3. So this is 2 volt, this is 0, this is 2 volt. So for this level, V naught is equals to M minimum plus delta V over 2 is equal to negative 4 plus the delta V is 2 divided by 2. So the answer is the middle value for this level is negative 3. Okay, let's try to another level. Quantized value for the level 1. So V1 equals to the M minimum for this level is -2 plus delta V is 2 divided by 2 is equal to 1, and the answer is -1. So the middle value for this level is -1 volt. So let's try to the next quantized value for level 2 and level 3. So simply we can say that here the quantized value is 1 volt and here is 3 volt. And then we need to build up the PCM system, which is the table of PCM, and determine the voltage range for each level. So that's all for this part. Let's continue to chapter 4, part 3. Alright, stay tuned and thank you.